Welcome to our class. So here are the basic trigonometric identities, and we are going to derive them all using the tangent, sine, cosine, hexagon. So here, sine would mean that is equal to 1 divided by cosecant. So it means to say sine theta is equal to 1 over cosecant theta. Okay? And cosecant theta will do the same. That will be 1 over sine theta. So for cosine theta will now be 1 divided by secant theta. And secant theta will also be equal to 1 divided by cosine theta. For tangent theta, we have tangent theta is equal to 1 divided by cotangent theta. So cotangent theta here is equal to 1 divided by tangent theta. These are the reciprocal identities. If we observe the tangent, sine, cosine, hexagon, it will provide us a product that is equal to 1 if we look into the opposite of each. So if you have cosine, the opposite is secant, the product is equal to 1. That is proven also in the reciprocal identity that sine theta times cosecant theta is really equal to 1. So the product of sine theta and cosecant theta is 1. It is also true to cosecant theta and sine theta that is equal to 1. So this is true and it will provide us this product. Also, cosine theta times secant theta, you see they are opposites. So the product of cosine theta and secant theta is 1. Also the same with secant theta times cosine theta. So we have secant theta times cosine theta is 1. So the product of tangent and cotangent is also 1. The next identities are the quotient or ratio identities. If we look into the tangent, sine, cosine, hexagon, and our movement is this way, it means to say that tangent of a function is equal to sine over cosine. Okay, so in the ratio or quotient, first ratio identity is tangent of any angle is equal to the ratio or the quotient of sine divided by cosine. So if you look into cotangent and our movement is this way, cotangent is equal to cosine divided by sine. Remember that cotangent theta is equal to cosine theta over sine theta, and the movement here is clockwise. Okay? Now, we can also do the same using cosecant theta, and the movement is clockwise as well. So, we are now involving cotangent and cosine. So, meaning to say, cosecant theta is equal to cotangent theta over cosine theta if you look into this relationship. And let's try to prove that. We prove that cosecant theta is equal to this. Okay? We can separate. We have 1 over cosine theta. Cotangent is now here. The product is still this one, so walang nagbago. Okay? Cotangent theta is equal to cosine theta over sine theta, and that is according to the quotient identity here, times 1 over cosine theta. Remember that we can cancel out cosine theta and cosine theta here. So what is left? We have 1 over sine theta. We know also that 1 over sine theta is equal to cosecant theta. So it means to say, it is true. It is now true that cosecant theta is equal to cotangent theta over cosine theta. Secant theta is also equal to tangent theta over sine theta. Let us prove that. Secant theta is equal to tangent theta over sine theta. We factor it out, so we separate tangent theta over sine theta. And here, tangent theta is equal to sine theta over cosine theta, and multiply that to 1 over sine theta. We can now cancel out sine theta here. So what is left? We have 1 over cosine theta. But 1 over cosine theta, we go back to the reciprocal identity here. 1 over cosine theta is secant theta. So we can now replace 1 over cosine theta into secant theta. And we can now observe that they are the same. You see? This hexagon is very helpful in understanding the different identities. So from this hexagon, we already proved that cosecant theta is actually equal to cotangent theta over cosine theta. And secant theta is equal to tangent theta over sine theta. Okay? But if in your mind, if you think that tangent theta is secant times cosecant theta, let's check if that is true. And for us to, maybe we can generalize another. So cosine theta times cosecant theta will give us cosine theta, cosecant theta, and that is equal to cotangent theta. Now we're going to find cosine theta in terms of cotangent theta and cosecant theta. So divide both sides by cosecant theta. So here, we have cosine theta is also equal to cotangent theta over cosecant theta. That is from here. So from this identity, we can say now that sine theta is equal to tangent theta over secant theta. Do you know that we can also find other identities after observing that these two adjacent sides of a function, their product is this function? And through the quotient identity, we know that tangent theta is equal to sine theta over cosine theta. So we can just change sine theta over cosine theta here into tangent theta. And here we can observe they are the same. So let us prove it, that sine times secant is equal to tangent theta. So let's have tangent theta is equal to sine theta times secant theta. Remember that secant theta can also be written into 1 over cosine theta through the reciprocal identity. Okay, so we bring down or copy sine theta. And observing that the product of sine theta times 1 over cosine theta is sine theta over cosine theta. And through the identity, reciprocal identity, so we already proved that tangent theta is equal to the product of secant theta times sine theta. So should we say also that tangent theta times cosecant theta is secant theta? Let's try it. So secant theta is equal to the product of cosecant theta times the other, that is tangent theta. We know that cosecant theta is equal to 1 over sine theta, that is by reciprocal identity. And tangent theta is equal to sine theta over cosine theta. So as you observe here, we can cancel out sine theta. Okay? So what is left? We have 1 over cosine theta. But 1 over cosine theta is the reciprocal of secant theta. So we can replace that into secant theta. And they are the same. So what about cosecant theta? Let's prove if that is a product of secant theta and cotangent theta. So we have cosecant theta is equal to the product of secant theta and the other adjacent function cotangent theta. Okay, so secant theta here is 1 over cosine theta. Change cotangent theta to its quotient identity, and that is cosine theta over sine theta. We can now cancel or eliminate cosine theta. The answer is 1 over sine theta. And 1 over sine theta is the reciprocal identity, or that is equal to cosecant theta. Okay? So they are just the same. So it means to say that this cotangent theta is the product of these two. We have cosecant theta times cosine theta. While cosine theta is the product of the two adjacent functions, so we have sine theta times cotangent theta. So this sine theta is equal to the product of the two adjacent functions, tangent theta times cosine theta. You can also prove, okay, take a look at this. If you say that cosine theta is equal to 1 over secant theta, if I square this 1, will also give me square of 1 over secant theta. So the square of cosine theta is written this way. Okay? And the other is 1 over secant squared. Yeah. So that is the proper writing. So it means to say also, if I let this be 3, this must also be 3. It doesn't give any change to 1 because 1 raised to any number remains to be 1. Okay? So another, if you say that tangent theta is equal to sine theta over cosine theta, if I raise this to 4, so I will also raise this to 4 for them to be equal. So what will this have look like? It will be, okay, write 4 there, and this is theta. So it means tangent theta, the quantity raised to 4. So by the rule of the exponent, this will look this way also. This is raised to 4. It cannot be that if you deal with cosine 45 degrees and you equate it to 1 over secant 20 degrees. It cannot be because 45 is not 20 degrees. Okay, so it means to say you need to partner it to 1 over secant 45 degrees. For us to say 45 degrees is to 45 degrees. We cannot also say that tangent 20 degrees is equal to sine, cosine, where in fact this is 30 degrees, the other is 30 degrees. Now in answering this particular problem or doing or performing the identity, it must be clear to you that when we say theta, you are just referring to one angle measurement. It cannot be, even though you say that cosine theta is equal to 1 over secant theta, it is clear that theta must be theta. When you are memorizing identities, always remember that the angles must be the same. Okay? Well, we know that tangent theta is equal to sine theta over cosine theta. But be very careful that when we refer to angle measurement, if you say this is tangent 90 degrees, then it must be true that you relate it to sine 90 degrees to be the same and cosine 90 degrees. Because if this is 80 degrees, for example, that is not true. From these tangents, sine, cosine, hexagon, we can also find other identities. We call that identities as the Pythagorean identities. Okay? So according to this hexagon, you see addition here and this is 1. There's also equal sign here. It means that when tangent squared theta is added to 1, that is equal to secant theta. So it means that tangent squared theta here, tangent squared theta plus 1 is equal to secant squared theta. So also, cotangent squared theta here plus 1 is equal to cosecant squared theta. So we have the next. Cotangent squared theta plus 1 is equal to cosecant squared theta. Also, sine squared theta plus cosine squared theta is equal to 1. So we have sine squared theta plus cosine squared theta is equal to 1. These Pythagorean identities can also be supported using the idea of the equation of the unit circle. We know that the equation of the unit circle is x squared plus y squared is equal to 1. We also know that x here is cosine theta. Okay, so we have cosine any angle theta. Then there's a square here, so square cosine theta. Y also is sine of any angle theta, so square as suggested here is equal to 1. And the squaring cosine theta will give you cosine squared theta plus sine squared theta. You see, from the equation of the unit circle, we can derive this identity from the hexagon. Remember that in the general form, before we have the equation of the circle, this one here comes from the square of r squared, because r is a radius, so it follows c squared. So here we go back and write it into r squared. So from this equation, we try to divide both sides by x squared. So we can cancel out x squared and x squared here, so we have 1. So what is left here? We have y squared over x squared is equal to r squared over x squared. Factor out. So we have y over x squared is equal to the square of r over x. But y over x here, y opposite, x adjacent, and this is the reference, that is equal to tangent theta. So substitute. This is 1 plus tangent theta. And r over x, hypotenuse over x, the adjacent, represents, okay, this r over x is a representation of the reciprocal of what we call the secant function. Because we know that cosine theta here is x over r, where this is r. Okay? And the reciprocal of this is secant theta, which is r over x. So this is r over x. So replace that into secant of any angle theta and square it. So we have 1 plus tangent squared theta is equal to secant squared theta. And you see, we were able to get this identity compared to what we got from here. So a while ago, we divided the equation by x squared. Now we divide both sides by y squared. So we have x squared plus y squared is equal to r squared. Divide both sides by y squared. And you observe what's going to happen. So this will be 1. So we have x over y. We immediately factor it out. So square of x over y plus 1 is equal to the square of r over y. And if y over x is for tangent, this x over y is for cotangent. So we have cotangent of any angle theta plus 1. R over y represents cosecant of any angle theta, and we square that. So we have now square of cotangent theta is equal to cotangent squared theta plus 1 is the square of cosecant theta. So the third Pythagorean identity is also derived the same way as we have here in the hexagon. So let us try to use these three identities if we have angle measurement, let's say theta is equal to 30 degrees. Let us try to use the first. Let's have the square of sine theta plus the square of cosine theta is just 1. So let's see if that is really equal to 1. We know that sine theta, first let's try to illustrate. If this is 30 degrees as a reference, side opposite it has a length of 1/2. The other is the square root of 3 over 2. Okay, so sine is the opposite and that is 1/2, the unit circle. So we have sine 30 degrees, so we square that, plus cosine 30 degrees square is equal to 1. Okay, and sine 30 degrees opposite is 1/2 on the unit circle, so that is 1/2. We square 1/2 and the other is automatically square root of 3 over 2 because they are partners. Okay, the adjacent side. Square root of 3 over 2 is equal to 1. 1/2 times 1/2 will give you 1/4. Square root of 3 is 3. Square 2 is 4. So 3 over 4. 1 plus 3 is 4. Similar fractions. Okay? See, they are the same. And that is true to all angles, provided that they have the same angle. We can also prove tangent squared theta plus 1 is equal to secant squared theta given that theta is 30 degrees. Okay? So we have tangent 30 degrees plus 1. We square tangent 30 degrees, so we have secant 30 degrees square. Tangent 30 degrees is opposite over adjacent, so we have 1/2 over square root of 3 over 2. We square that plus 1. Second function is the reciprocal of cosine. So cosine 30 degrees is actually square root of 3 over 2. Get the reciprocal of that, so 1 over square root of 3 over 2 square. Okay, so here we can cancel out 2 and 2 here, and what is left? We have 1 over square root of 3. We square that plus 1. The reciprocal of square root of 3 over 2 is equal to 2 over square root of 3. So we square that. Square 2 is 4. Square root of 3 is 3. Okay? And in here, square 1 is 1. Square root of 3 is 3. So 1/3 plus 1. But this one here can be written into 3 over 3. Make it similar fraction. So we have 1/3 plus 3 over 3 is equal to 4 over 3. 1 plus 3 is 4. So we have 4 over 3 is equal to 4 over 3. They are the same. On this next identity, we have the square of cotangent theta plus 1 is equal to the square of cosecant theta. Okay, we also use theta that is equal to 30 degrees, so we have cotangent 30 degrees is square that plus 1 is equal to cosecant 30 degrees square that. Okay, cotangent 30 degrees, tangent 30 degrees is 1 over square root of 3. So we need to say cotangent 30 degrees is the reciprocal of 1 over square root of 3. So we have square root of 3 square that. Cosecant 30 degrees is the reciprocal of sine 30 degrees. and sine 30 degrees is 1/2. So reciprocal of 1/2 is 2. So we have 2, square 2. Square root of 3 is 3. Cancelling radical sign with index that is 2. Plus 1. 2 squared is 4. So 3 plus 1, 4 is equal to 4. These identities are very helpful, especially when we are dealing to more complicated trigonometric expressions or equations. Because with the use of these identities, we can actually simplify equations, simplify trigonometric expressions, and made it even better in understanding. Writing trigonometric functions is very crucial. Remember that if you write sine 30 versus sine 30 degrees, these two are not the same. Because this sine 30 would mean 30 radians, okay? Meaning to say it is not in degree measure. But this one is in degree measure because of the symbol degree here. Meaning to say they are not equal. So don't get deceived when you are using your calculator, because if you input sine 30 in your calculator and the calculator is in degree mode, then it will appear as 30 degrees, which is not 30 degrees as expected in proper writing. So when we are writing, it must be specific that if you have 30, and that must be 30 radians. And if you have 30 degrees, that is 30 degrees. Meaning to say 30 is not 30 degrees. Consider this OA as the terminal side of an angle that is rotating counterclockwise, and I name that as theta. Okay? And what if we have a particular side that is considered to be a mirror image of 0A? And this OB is the mirror image of OA. And since that is formed clockwise, so that is a mirror image. So since that is clockwise, that is negative theta here. So theta and theta are the same. However, you have a negative sign indicating that this one is rotating clockwise. These two sides, terminal sides, are reflections of each other. So if this point A, terminal point A, has coordinates x, y, then since A and B are reflections, okay, then this B will also have the same x coordinate with that of A, and that is x. The y coordinate of A, which is y, will become a negative y. The reason is because this point B is already found on the fourth quadrant. So if we try to get the cosine and sine of this theta, we know already that cosine theta is equal to x, so that is the x coordinate. But this negative theta, if we try to get cosine of this negative theta, can also provide us the same. Why? Because they are reflections of each other. This is also x. So we have cosine negative theta is equal to x. And as you observe, they are just the same. So it means to say that cosine of angle theta is equal to cosine of negative theta. Because we know that theta and negative theta are equal in degree measures. Cosine theta is equal to cosine negative theta are the same because the angle measurement is the same. However, the rotation is not the same. Other is counterclockwise, the other is clockwise. Okay? Now, if we try to observe sine theta and sine negative theta, we see here that sine theta is y. So we have sine theta is equal to y. However, sine negative theta or sine of negative theta is equal to negative y simply because this point B is already found on the fourth quadrant, so the y coordinate must be a negative. Okay? Then how can these two be the same? So sine theta is equal to y, and sine negative theta is equal to negative y. So for them to be the same, one must be negated, or there must be a product of negative 1 and the function. So it means to say that sine theta will only be equal to sine negative theta if one of them will be multiplied to negative 1. So if I say this is negative sine theta, equate that to sine negative theta. And we know that sine theta is y, and negative times y, negative y. So you see they are now the same. So here we were able to form another identity. So for tangent function, tangent theta here will give us positive value because point A here is already found on the first quadrant. However, tangent negative theta will give us negative because point B is found on the fourth quadrant. For them to be the same, one must be negative, or get the product of the function and negative 1. So it means to say also we can write that tangent theta to be the same or equal to tangent negative theta, I need to negate this negative tangent theta for us to provide the same. Remember that tangent theta is equal to sine theta over cosine theta, which is y over x. So there is negative sign here already. And tangent negative theta is already negative y over x because in here, this is negative y, this is x. Cosine theta is equal to cosine negative theta, and these two will give us both positive. Okay, based on the illustration. It means to say also that if these are both positive, can also be both negative. And the reciprocal of cosine is secant. So we can say also that secant theta will give us, or that will be equal to secant of negative theta as well. Negative sine theta is equal to sine negative theta. Will also follow that cosecant theta, negate cosecant theta will give you equal value to cosecant of negative theta. So you see we already have the fourth and we have the fifth. Now on tangent, we know that negative tangent theta will give us equal value to tangent of negative theta. We can also say that negative of cotangent theta will give us the same value to cotangent of negative theta, and that is the sixth identity. If we try to observe, cosine theta is equal to cosine negative theta, okay? But in here we have negative of sine theta, negative of tangent theta, just to have equal values. Now, there are conditions. If f of x is equal to f of negative x, just like cosine and secant function, they follow. Observe that cosine theta is equal to cosine of negative theta, and they are just the same. Okay? Secant function will also follow. Secant theta is secant of negative theta. We call this identity as the even function identities. They are the even functions. But if f, okay, if negative of f of x is equal to f of negative x, just like negative sine theta is equal to sine of negative theta, negative tangent theta is equal to tangent of negative theta, together with negative cosecant theta is equal to cosecant of negative theta. These four trigonometric identities are what we call the odd functions. So we have the even functions, the cosine and secant, and the odd functions, sine, tangent, cosecant, cotangent. Remember also that it follows that when other points are found on quadrant 2 or quadrant 3. For example, we have point C here, and the angle measurement here, let's say for example, is beta. And there is another angle wherein they share the same reference angle. Let's say these two are the same. Okay? Now, therefore, I will name this angle in clockwise rotation as negative beta, and it still follows all these rules we just provided. Okay? Because in here, point C has coordinates negative x and positive y. And this, let's say this is point B, it has coordinates negative x, negative y. And as observed, x and x coordinates are the same, both negative numbers. They don't have the same y coordinates. In sign, they are not the same. No, the other is positive, the other is negative, so it's still carried. So let us try to assign degree measures for theta here. And this theta is again counterclockwise rotation. Let's say that is 60 degrees. Okay? So what are the coordinates of point A, wherein point A is a terminal point generating angle that is 60 degrees. So let us try to get the trigonometric points of point A here if theta is 60. Well, we have a guide, okay? So if this is 60 degrees, then this must be 30 degrees and this is 90. The side opposite 30 degrees is 1/2, okay? Opposite 60 degrees is square root of 3/2. Therefore, the x-coordinate of point A is cosine 60 degrees. Cosine 60 degrees, the adjacent side is 1/2. So this must be 1/2. So the y-coordinate is square root of 3/2. Okay, so if there is a particular angle clockwise rotation and they have the same measurement which is 60, however that is clockwise, if this is theta, then you can have negative theta, and that is negative 60 degrees. So it means to say they have the same reference angle, then they must have the same coordinates. However, it is only x that is the same, positive 1/2, and y will be negative square root of 3/2. So meaning to say, cosine of 60 degrees is equal to cosine of negative 60 degrees. Okay? But sine 60 degrees, which is square root of 3/2, is not equal to sine of negative 60 degrees because sine negative 60 degrees is negative square root of 3/2. So it must follow that you need to negate one of them, or let's say negative of sine 60 degrees, and that will be negative square root of 3/2. For them to be the same, that makes this odd function essentially understanding equality. We can also say that cosine 150 degrees is equal to cosine of negative 150 degrees. Why? They have the same reference angle. The reference angle of this angle 150 degrees is 30 degrees. So meaning to say, if you draw a 30-degree triangle, 30, 60, 90 degree right triangle, 30 degrees, so this is 60 degrees. This must be 1/2, this is square root of 3/2. So cosine 150 degrees is square root of 3/2 in the triangle, but in the coordinates, that must be negative. So we have negative square root of 3/2. So if you try to draw that, this is 150 degrees. This is 30 degrees as a reference angle. This one is 150 degrees. The other is clockwise rotation. This is negative 150 degrees. And as observed, they have the same reference angle. As observed, they have the same reference angle. 150 degrees has a reference angle 30 degrees, and so with negative 150 degrees, we also have 30 degrees. Okay, reference angle. Now, they are just similar in sign because the other is counterclockwise, the other is clockwise. But when it comes to trigonometric values on cosine, they share the same value. Why? Because these two are both negative. Okay, quadrant 2 and quadrant 3. But for cosine, for sine, I mean sine 150 degrees, this will give us positive, while the other sine of negative 150 degrees will give you negative because y coordinate here is negative. So I mean to say, this must be negated for them to be equal. And the answer is negative 1/2 is equal to negative 1/2. Okay, consider this terminal side which is generated by an angle theta here. Okay, and I will create a triangle. So I will draw an imaginary vertical line here. So I'm able to create a right triangle. Okay, so imagine if I add a 90-degree angle from this theta. So I have here (90 degrees). So theta plus 90 degrees will now illustrate the generated angle in counterclockwise. The angle is in standard position. The measure of the angle is theta plus 90 degrees. Remember that the sum of the interior angles of a triangle is 180 degrees. So if you have 90 degrees here added to theta, then you need to add a particular angle here. So there is an angle here to form 180 degrees. Now, we know that half of this circle, imagine this one as a circle, the radian measure in the unit circle is that is pi, and that is 180 degrees. It also follows the rule of supplementary angles, that when you add angles, this part, this is 90 plus here, will give you 180 degrees. Now, if this is theta, and this is 90 degrees, we'll also picture out the same illustration here, 90 degrees and theta. So it means to say, the angle here is also equal to this angle. Now imagine also, if I create here an imaginary vertical line, so I also have another triangle. So it means to say, this angle here is the same to that. So this theta is found here. Now let us name the coordinates. Let's say this is point A. Let us try to know the coordinates. The x here, the length of x, or the length of the horizontal length of this point to the other. Let's say that is x. This also represents y. X is the length opposite to this angle. The other is theta. Its opposite side has a length y. So the coordinates of point A are x and y. And if we add 90 degrees to this angle, so let's say this angle measurement here is represented by theta. So this is also theta, for us to have accurate representation, okay? And the side opposite theta here is y, and opposite beta is x. So that's why we have these coordinates. Now, if we have the rotation, if we added 90 degrees here, it follows that beta here will be found already in this portion. To follow 180 degrees total of theta plus 90 plus beta, okay? And the length of the side opposite B is x. So it follows that this will become x, okay, when it comes to length. And the side opposite theta here is y, so this will become y. So if I say the point here is B, the coordinates of point B, recognizing its location, which is quadrant 2, x will become, the x coordinate will become negative y, and the y coordinate is x. Now we assign the length of the hypotenuse or the hypotenuse as r, and this is also r, okay? Okay, so in here we just need to remember x and y. In point A, x here represents cosine, okay? Cosine of any angle theta. So we have cosine theta is equal to x, because we are now talking about unit circle, okay? So in the next point, point B here, there is x here. This x here will again represent a trigonometric value, but this x becomes a y coordinate, and when we talk about the y coordinate, it refers to the sine function, okay? So it means to say that sine theta plus 90 degrees here is equal to x. So we have sine theta plus 90 degrees is equal to x. Since cosine theta is equal to x and sine theta plus 90 degrees is also equal to x based on the illustration here. Okay, this is y coordinate. X is just a representation of the y coordinate and x here as the x coordinate. So here we can say therefore that cosine theta is equal to sine theta plus 90 degrees. But if you observe y here, we know that that is a representation of sine theta. The y here is equal to sine theta. Okay? But if we look into this, we have negative y as a rotation. That is the effect of the rotation. This negative y represents cosine of theta plus 90 degrees. So we have cosine of theta plus 90 degrees is equal to negative y. So for them to be the same, these two, for them to be the same, we can say that cosine of theta plus 90 degrees is equal to negative, because this one is already negative y, so this must be negative sine theta. Now we observe tangent theta plus 90 degrees. So we have tangent theta plus 90 degrees. And we know the tangent function includes opposite side over adjacent side. Okay? Tangent theta plus 90 degrees in this illustration is equal to sine theta over cosine theta. Remember that? And that is x over negative y. So we have x over negative y, which is equal to negative x over y. Okay? So we also know that cotangent theta is equal to x over y in the unit circle, where x is cosine theta and y is sine theta. And since that is a negative x over y, then we say that tangent theta plus 90 degrees in relation to cotangent theta, this must be negative cotangent theta for us to say that they are the same. So if I negate this, then this will be negative x over y. Let us prove this 3, okay? We let theta be equal to 30 degrees. So, let's try to check whether cosine 30 degrees is equal to sine. Let x be equal to 30, let theta be equal to 30 degrees, so replace theta here into 30 degrees plus 90 degrees. So we have sine 120 degrees. And if we try to draw a triangle just for our reference, if this is 30 degrees, then this is 1. Okay? And this must be square root of 3 over 2. So sine 120 degrees, since, or we proceed first, so cosine 30 degrees, the adjacent side of 30 degrees here is the square root of 3 over 2. So cosine 30 degrees is the square root of 3 over 2. However, for 120 degrees, if we try to draw that, 90 plus 30, so this one is 120 degrees. The reference angle of this is 60 degrees. So it means to say, if you have 60 degrees here, and this is 30 degrees, side opposite 30 degrees is 1/2, and this is the square root of 3 over 2. Okay, so sine 60 degrees in reference now, no? We talk about the reference angle now. You see that is already the shortcut, that is the importance of reference angle. So sine 120 degrees can also be sine 60 degrees. Okay? And that is equal to square root of 3 over 2. And they are equal. That makes it identity. So we try to prove this cosine theta plus 90 degrees is equal to negative sine theta, with theta is still equal to 30 degrees, okay? So replacing theta into 30 degrees, so we have 30 degrees plus 90 degrees will give us 120 degrees. And 120 degrees still illustrates this one. The reference angle is 60 degrees. So cosine, okay, adjacent side is 1/2. So cosine of 120 degrees is also cosine of 60 degrees, and that is 1/2. However, since we find the point with an angle of 120 degrees, which is in quadrant 2, we have negative, positive, then this must be negative 1/2, because we are now referring to the quadrant 2, that x must be negative. But sine 30 degrees here, sine opposite of 30 degrees is 1/2. Okay, that is positive because you can find 30 degrees in quadrant 1. So that is sine 30 degrees is 1/2, and because there is negative here, it will now give you negative 1/2. And you see, they are the same. So for tangent theta plus 90 degrees is equal to negative cotangent theta, we still use theta that is equal to 30 degrees. Okay, so we substitute. So we have tangent 30 degrees plus 90 degrees is equal to tangent 120 degrees. Okay, so 120 degrees is still, this is the representation. The reference angle is 60 degrees and tangent is opposite over adjacent. And since 120 degrees is found on quadrant 2, we expect to have negative value of tangent 120 degrees. The opposite side is the square root of 3 over 2, and that is sine. Sine 60 degrees and sine 120 degrees is the square root of 3 over 2. And cosine 120 degrees is 1/2, or that will be negative 1/2. Okay? So we already simplified it to have negative sign. The answer is, so we can now delete this. The answer is negative square root of 3. That is tangent 120 degrees. So what about negative cotangent 30 degrees? Okay, so if we have a 30 degrees, adjacent side is square root of 3 over 2 and opposite side is 1/2. Okay, so we have the adjacent side square root of 3 over 2, opposite side is 1/2. And negative, recognize that, so negative of this. And you see, they are the same. Okay, so we have negative square root of 3. Consider this as a terminal side. So there is a generated angle counterclockwise. Let's say that is theta. And I name the terminal point as point A, having coordinates x and y. So if I created, or I add 180 degrees from theta here, then imagine what's happening. So it will be like this. So in here I added 180 degrees. So from theta plus 180 degrees. Okay, so I have here theta plus 180 degrees. So imagine also that there is a generated angle here up to here. Since we're talking about the angle in standard position, theta plus 180 degrees represents this counterclockwise rotation, okay? But this clockwise rotation in angle standard position from x-axis here down to here represents a measurement that is theta minus 180 degrees, okay? That is a negative sign. So the imagination here is this is 180 degrees, okay? Removing theta from negative 180 degrees represents this measurement of the angle. So if this is theta, and we try to observe also that there seems to be a vertical angles here. So this is theta, this is also theta. So if they are the same, and as observed they are reference angles as well, then they share the same length of x and length of y. If you try to form an imaginary right triangle here, it's also here. So it means to say, if I name this point as point B, and the coordinates of point A here are x and y, B will have coordinates negative x and negative y, simply because B is found on the third quadrant. Now, observe that theta plus 180 degrees and theta minus 180 degrees are coterminal angles. They share the same terminal side. And based on the definition of coterminal angles and in relation to the coordinates on the unit circle, they also have the same coordinates as well. So it means to say cosine of theta plus 180 degrees is also equal to cosine of theta minus 180 degrees. Also, sine theta minus 180 degrees, or should I say plus, is also equal to sine of theta minus 180 degrees. And so with tangent theta plus 180 degrees is equal to tangent theta minus 180 degrees, simply because they are coterminal angles in the representation. And as we observe, cosine of theta plus 180 degrees is negative x here. So this one is negative x. Sine of theta plus 180 degrees, which is also equal to theta minus 180 degrees, is negative y. So I place here negative y. However, for tangent theta plus 180 degrees, which is also equal to tangent theta minus 180 degrees, will give you positive divided by positive is positive, negative divided by negative is positive, so that is y over x. And we know, with the reference of theta here, we know that cosine theta here is simply x. In the illustration, we also know that sine theta is y. Now, tangent theta is equal to y over x. Now, let's try to relate each. This is negative x, but this is positive x. So what will happen? So the rotation of angle by 180 degrees will provide us another identities. Okay? So it means to say that cosine, since we say already that plus 180 degrees and minus 180 degrees of theta is same, so we have cosine theta plus or minus 180 degrees is now equal. Since this is x and this is negative x, we just need to negate this to have the same value. So that is equal to negative cosine theta. So for sine theta, so sine theta plus or minus 180 degrees is equal to, so negate this to have the same, no? That is negative 1, so we will now have the same. So we have negative sine theta. So for tangent theta plus or minus 180 degrees will give us the same equivalent to tangent theta. So we have is equal to tangent. These are the identities. So we let theta be equal to 60 degrees. Sine theta plus 90 degrees is equal to cosine theta. We separate these two. And we substitute theta, that is equal to 60 degrees. So 60 degrees plus 90 degrees is 150 degrees. The reference angle of 150 degrees is 30 degrees. It is found on quadrant 2. So the y coordinate is positive, and that is 1/2. Cosine 60 degrees is found on quadrant 1, and cosine 60 degrees is 1/2. They are the same. Okay. So what about cosine theta plus 90 degrees? Should it be equal to negative sine theta? Let's prove it. Okay. So here, substitute theta, that is 60 degrees. So 150 degrees na ito, the total. So cosine 150 degrees is negative. Square root of 3 over 2. 150 degrees has a reference angle of 30 degrees and it is found on quadrant 2. That's why the x coordinate is negative. Okay, 60 degrees is on quadrant 1, but since that's negative, then the final answer is in negative square root of 3 over 2. So for tangent theta plus 90 degrees, which is equal to negative cotangent theta, we prove it. We let theta be still 60 degrees. And the tangent 150 degrees is negative square root of 3 over 2. And so with negative cotangent theta, where theta is 60 degrees, that will still give us negative square root of 3 over 2. You may use your calculator to prove it immediately. Okay, and the identity is really true. So let's try to prove sine theta plus or minus 180 degrees is equal to negative sine theta. We let theta be equal to 45 degrees. So 45 degrees plus 180 degrees will give us 225 degrees, and it is found on quadrant 3. So that must be negative square root of 2 over 2. That negative sign indicates negative y coordinate on quadrant 3. 45 degrees minus 180 degrees gives us negative 135 degrees. That negative angle is a clockwise rotation and it is found on quadrant 3. Then negative square root of 2 over 2, the same. Negative 135 degrees and 225 degrees are what we call coterminal angles. Then certainly they have the same values. Negative sine theta, so you see there is equality here. So see, sine 45 degrees is square root of 2 over 2, and because there is negative sign here, then negative square root of 2 over 2. For cosine theta plus or minus 180 degrees is equal to negative cosine degrees. We have the addition, we had the subtraction, then here 45 degrees plus 180 degrees gives us 225 degrees, and that is found on quadrant 3, and that must be negative. Okay, but in here negative 135 degrees is in quadrant 3, then we have negative square root of 2 over 2, and they are the same again because these two angles are coterminal angles. Okay, now cosine 45 degrees really is square root of 2 over 2, and because there is negative there, then that's negative square root of 2 over 2. So for tangent, 225 degrees still in quadrant 3, so negative and negative will give us positive value of tangent. Okay, and for negative 135 degrees still on quadrant 3, then we have positive. And tangent 45 degrees really gives us 1. Okay, meaning to say these identities really are true. Now, these identities are what we call co-function identities. That is, rotating an angle by 180 degrees and the other is 90 degrees. And well, all of these are all possible identities, and we can use it on the other more complicated identities as we go through. Okay.